Imagine yourself strapped in a private spacecraft, preparing for the thrilling journey back to Earth. As the countdown commences, your heart races. The anticipation of the re-entry process is palpable. The experience, while exhilarating, is fraught with complexity. The angle of re-entry is crucial. Too steep and your craft could incinerate in the searing heat of atmospheric friction. Too shallow, and the spacecraft risks bouncing off the Earth's atmosphere, sending it spiraling back into the abyss of space. Equally important is the speed of your spacecraft. It must be fast enough to overcome the pull of Earth's gravity, yet slow enough to withstand the extreme temperatures of re-entry. It's a fine balance, a dance with physics and thermodynamics. As your spacecraft aligns itself for this critical phase, one thought guides you. Precision is key. With the correct angle and speed, you are set for a fiery plunge back to Earth. As you begin your descent, the air in front of the spacecraft compresses, causing it to heat up dramatically. This is not your average heat wave, but a sweltering inferno that could melt steel. Picture this. The friction between the spacecraft and the air molecules, coupled with the compression of air, generates an intense heat, reaching temperatures up to 3,000 degrees Fahrenheit. That's hotter than molten lava. Now you may be wondering, how does one survive such extreme conditions? Well, it's all about the design of the spacecraft. Nestled within your private capsule, you're shielded by an advanced heat shield, a marvel of modern engineering. This shield absorbs and dissipates the extreme heat, ensuring the interior remains at a comfortable temperature. It's a bit like being inside an oven, but with the dial turned way down. Thanks to advanced engineering, your spacecraft remains a safe haven amidst the searing heat outside. Hold on tight, as the gravitational forces are about to give you a wild ride. As we plunge back towards Earth, the gravitational forces, or G-forces, start to take effect. These forces can peak at around 5 times the force of gravity we experience on Earth, a sensation we call 5Gs. Now, imagine feeling 5 times your own weight pressing down on you. This is what it's like during the peak of re-entry. It can make you feel heavier, as if an invisible force is pushing you down into your seat. This might cause some discomfort, but don't worry. It's generally tolerable with proper training and preparation. Astronauts train for these conditions, learning to withstand these forces and even function under them. They engage in rigorous physical training and simulations to prepare their bodies and minds for the experience. So buckle up and prepare for the ride of your life. Experiencing these forces firsthand is like a roller coaster ride on steroids. Brace yourself, the final challenge is here. The landing, the last phase of re-entry, is a crucial one, where the spacecraft's velocity must be significantly reduced for a safe touchdown. This is usually achieved by deploying parachutes or firing retro rockets. These mechanisms work to slow down the craft, transforming what would be a catastrophic crash into a manageable deceleration. Yet this transition isn't without its effects on the body. You might feel a bit lightheaded as the sudden deceleration causes blood to rush away from your brain. It's an odd sensation, akin to standing up too quickly, but it passes quickly as your body adjusts to the change in speed and gravity. The landing might be a jolting end to a smooth journey through the cosmos, but it's a necessary and carefully calculated part of returning to Earth. Congratulations! You've survived a journey few have ever experienced, the intense and exhilarating process of spacecraft re-entry. That concludes this week's episode of Cosmic Curiosity. Don't forget to like, comment, and subscribe to Universal Factz. Thanks for watching.